All right, so you've learnt how to expand. What we're now going to do is back the truck up and factorize, because all factorizing is the reverse of expanding. All right, so remember in year 9 what you did was took things like this. So if you had an expression like 3x squared plus x, what you would do is look for a common factor and yank it out. Okay, so here we're going to pull out x as a common factor. And then what we would do is think about what in this position would make 3x squared. Well, that's just 3x. And what in this position would make positive x, which would be a 1. And that would be called fully factorized. Now, at this stage, a lot of you might enjoy the process, but many of you won't actually know why we do it. So there's more on that later. So this process is really, really important. We're going to use it for something that you don't know yet. Okay, so you're going to have to kind of try to just trust me at the moment, practice the skill, yeah, we'll see how we go. All right, so let's do this. We're going to look at this expression here and note the highest common factor. So it's got an x and an x. 3 will go into 6, so it's 3, so it's going to be 3x. But what I want you to do is concentrate on pulling the negative out as well, okay, so that the first term is a positive. Okay, that's really important. So we're going to say that the highest common factor at this stage is negative 3x. Let's pull it out, open up our brackets, and try to reconstruct this term here. So negative 3x multiplied by what gives you negative 3xy? Well, it has to be y. Now, I've got a negative and I need to make a negative here. So this must be a positive because a negative times a positive will be a negative. Now, negative 3x multiplied by what gives me negative 6x? The answer is 2. All right, and what you could do somewhere on the page is just double check that you've done that right by just expanding it. Negative 3xy, take 6x. It's correct. Another way you can check it out is by going to Action, Transform, Factor, and there's 2 types of factors. Let's use our factor and see what that does. Negative 3xy takes 6x. And there we go, it's yanked out negative 3xy plus 2. Okay, so again, note that the calculator also pulls out the negative. Okay, that's an important step there. All right. To factorize dots, we'll need to consider what we call the perfect square identity. Okay, so that's the perfect square identity that we saw in the last lesson. So this is what we're going to do. What we're going to notice is that we've got 2 terms. Okay, so when we're looking for whether we factorize using this dots technique, it has to have 2 terms. Okay, that's what's required. And it must have a neg between terms. Okay, so it has to have a negative sign because, to be honest, girls, if we don't have the difference, okay, then we can't use it because it's not the difference of perfect squares. So here we go. Let's look at this. Okay, we've got a difference and we've got 2 terms. Now what we're going to do with these 2 terms is make them perfect squares so that we can use the difference of perfect squares. Right, so let's convert this into a perfect square. Now, how would we do that? I'm going to write this as 3 squared, x squared, take away 4 squared. And now I'm going to write it as 3x all squared, take away 4 squared. And now we truly do have the difference of perfect squares. All right, so what we do to finish the job here is we write 3x take 4. Okay, so that goes there with a negative sign in there. And then we do the reverse, okay, 3x plus 4. All right, so that goes there, and the negative gets reversed. All right, and again, you can check that out by expanding it. Now in a test, don't do this directly underneath, do it somewhere else. So a lot of you guys will write that, get it perfectly right, and then do a check by re-expanding it directly underneath, and that's your final answer. That's what I've got to take as your answer. So don't do it directly underneath. sort of go somewhere else on the page and just do a quick check or indicate that you're checking. Right, so this, if we were checking it out, would be 3x plus 4, take 4, 3x plus 4, which was 9x squared, take or plus 12x, take 12x, take 16. Notice how those cancel out, giving us 9x squared take 16, which was our original expression. Must be right. Right, this one here, what we notice is that we've got two terms, we've got a different sign, and we need perfect squares. This one's easy enough. That's going to be written as 2p all squared. Now, how do I write negative 20 as a perfect square? Well, being manipulative is probably not something you want to be called, but in mathematics, if I call you, ooh, you're quite manipulative, that's good. That's good in mathematics. So let's be a little bit manipulative with this 20 here. So what we're going to do is I'm going to write this as negative or take away root 20. Not 20, root 20. This is a little cheeky here, girls, but what I'm going to do is bracket this and square it. Okay, because root 20 squared is just 20. Now, what have I achieved here? Well, I've achieved a lot, because what I've done actually is written this as the difference of perfect squares. All right, now what I'm going to do is proceed to write it in that form. So I'm going to write 2p take root 20, 2p plus root 20. Now notice this identity here has it as the plus first and the minus second. We can put the minus first and the plus second because these are being multiplied, so it doesn't matter what order you do it in. I always go the negative first and the positive second because, well, I feel like it. All right, now this one isn't quite finished. Okay, so what we're going to do is we recall that simplifying surds is important. And this is going to be root 4 times root 5, which is 2 root 5. So I'm going to write this as 2p take 2 root 5, 2p plus 2 root 5. And notice also now that what happens with this is I can actually pull 2 out as a common factor of this and 2 out as a common factor of this. So it's actually going to come out of here 2p take root 5 times 2p plus root 5. And notice that this is all going to be able to be multiplied together. So this will actually be 4p take root 5, p plus root 5. And there it is. All right, so that would be considered fully factorized. All right, this one here, okay? Now, you might look at this and go, ooh, negative sign, but it's not two terms. Well, yeah, it is, okay? This is considered one term, and this is considered one term, okay? So it's just a binomial term, okay? So what we're going to do is consider that one thing, or a perfect square and a perfect square. Right, so here goes. What I'm going to do is, it's already set up. That's a perfect square, and that's a perfect square, and that's the difference. So I'm just going to write this, x plus 3 in brackets, take x take 2. So that goes there, that goes there with a negative sign. Then I'm going to do x plus 3 plus x take 2. Close my brackets. All right, now that's just that identity there. So it's going to be same first term, same second term, negative. Same first term, same second term, positive. All right, so now let's expand this out. So we're going to go x plus 3 take x plus 2. So I'm just distributing negative 1 across those two terms there. And over here we've got x plus 3 plus x take 2. All right, let's start to clean this up. X take x, that cancels out. 3 plus 2 is 5. X plus x is 2x. 3 take 2 is 1. And there's our answer. Okay, if there's no common factor across all four terms, so we've got a four-termer now, but there are different common factors for two pairs, they can be factorized in the following way. Right, so what we're going to do with this one here is use this grouping 2 and 2 method. Now you'll be familiar with this from last year because I know in Year 9 they teach you the grouping 2 and 2. So what I'm going to do is group this part and factorize them separately. So let's see what happens when I do that. So I'm going to factorize this part by yanking out x. Okay, and that's going to be x take h to reconstruct this part of it. Now I'm going to concentrate on the right part of it. Okay, now what's the common factor? Well, it's just 1. X take h. All right, but notice what it does here is it gives us this factor and this factor. Okay, and that's actually a common factor that I can pull out. So I'm going to grab x take h out as a common factor. Now, x take h multiplied by what will give me this? Well, the answer is going to be x. And x take h multiplied by what will give me this? Well, it's going to be 1. Okay, and so there we go, we've got that fully factorized. Okay, so note that when we want to use grouping 2 and 2, we've got to have 4 terms. So if I give you a question in the test and it's got 4 terms in it, invariably, girls, it will be a grouping 2 and 2 problem. All right, so there's the work there that I'd like you to do, exercise 5B. That's enough to keep you busy. There's a lot of questions there and a lot of repetition, some really tough problems there as well. So get stuck into it and let me know if you have any problems.